Hey y'all, I want to show you how to subtract fractions. So subtracting fractions is just like adding fractions. So let's get started. The goal is, right, with this expression here, 7 over 11 minus 2 over 11. The goal is to make sure the denominator, the bottom part of the fraction, is exactly entirely the same. So here, I got an 11 and I got an 11 here. Totally identical, totally the same. So this idea that to make the bottom numbers the same is what I like to call the boot and hat method. So the boots and hat method is pretty straightforward. It's pretty easy to visualize. So basically when you wear shoes or boots, they got to be the same exact shoe, right? You can't wear two different shoes. It's just not the norm. And your hat that you put on your head, it could be any hat. It doesn't matter. It could be a top hat. It could be like a little baseball cap. It doesn't matter. But the shoes totally gotta match, no exception. And it's the same thing here with adding and subtracting fractions. You basically have to have the exact same shoes on. So if we look here, I have an 11. That boot matches this boot precisely and exactly. It's not an 11 on one side and a 12 on the other side, right? It's not a 1 on one side and an 11 on the other side where they almost look the same. They're totally identical. So this problem, once you get the bottom numbers exact, you can totally start solving the problem. You're pretty much almost done, right? But we got to make sure they're equal at the bottom. So what do I do next? Once I establish that it's totally equal and the same at the bottom, well, I can go ahead and start subtracting. So 7 minus 2 is 5. And what about the bottom? Do I do 11 minus 11? Because what happens is it gives me a 0. And in the world of fractions, this isn't common. We don't do this. Like, this is not something we do, right? It's considered undeterminate. So we can never ever have a 0 in the bottom of a fraction. If you have that, there's a likelihood we got to look at our work and see if there's something we can change, because it might be something that we messed up on. So what do? Well, I'm going to keep the 5 at the top because there's nothing wrong with that one. I can't have a 0 at the bottom. So we're not doing 11 minus 11. What we're going to do is we're going to look at the bottom and see that there's 11s. It's nothing but 11s. So guess what goes there? 11. Because what we're showcasing is the boots we had. We don't got to repeat it twice. It's not going to be 11, 11. We're just going to do 11 because we don't need to repeat it. Right? There we go. 5 over 11. We got the same boots on. Here, same boots. Here, same boots. Hat, totally chill. It doesn't matter what the hat is. 5 over 11 is the final answer. We're done. We can move on to the next problem because that's the answer. So now, for the next problem, I have 3 over 4 minus 1 over 7. Okay, so what do I do? Because I'm looking at the bottom, the boots, the shoes, and they're totally different. I got a 4 and I got a 7. What do I do? Because, like, they're not the same. I don't know. Well, I have to make them the same. I have to do something to make them the same. What do I do? Okay, well, we can do like a flip method where anything that's on this side we throw over here, anything on this side we throw over there, and then we multiply. So let's try that. Let's put the 4 here. Let's put the 7 here. Because we're just flipping, right? We're just going to repeat and flip or whatever. Well, I mean, it's guaranteed because we're multiplying. It's guaranteed we're going to get the same number on the bottom. But here's the thing. You got it set up. Maybe it's going to be right. Maybe it's not. We'll have to see. But whatever you do at the bottom of this house, you got to throw upstairs. So I'm going to put a 7 here because there was a 7 downstairs. Moving on to the second fraction, totally separate house. I'm going to see what I put down there, which was a 4, and I'm going to move it upstairs also. It's so critical you do this. This is a step that sometimes people skip. We can't skip this step because you're going to end up with a different answer. The numerator, the top number, is going to be totally different than what you need because we have to still generate the correct answer. So let's try to figure this out. What is 4 times 7? Well, I have a 28, right? So let's do a 28 minus, because it was asking us to subtract, 7 times 4, which is also 28. It looks like what we did, the flipping method, was totally correct. We came up with the same exact boots, so we're doing great. What about the top? Well, we we had to move everything downstairs, upstairs, right? So I had to multiply 3 times 7, which gives me 21. And then 1 times 4 gives me 4. Great. Everything is set up perfectly. I can do the very last step, which is solve the problem, and I'm totally done with this question. How do I do this? Well, if you remember, we gotta keep the same boots on, right? So these boots are the same, this boot's the same. What about the top part? 21 minus 4. What does that give me? It gives me 17. I can't reduce this any further, so this is, in fact, the final answer. It's pretty straightforward. Okay, so let's move on to the third one. I have 2 over 3 minus half, or 1 over 2, right? Let's call it 1 over 2. How do I do this one? Can I do the flip method where I just throw a 3 over here and throw like a 2 over here? Can I do that? Yeah, certainly. Certainly we could. But let's see. How about let's do a bookkeeping method just so you can get used to a different way of determining it. Because sometimes it's not that easy. Sometimes the numbers are way, way, way too big. Sometimes they're way too small. Let's see. So what you do is you're going to take the first number and the second number and you're going to write it down. I have a 3 and I have a 2. So I put a 3 here and I put a 2 here. Let's put the 2 here. I want to keep it separated. So I have 3, 3, 3. Let's do 4 of them. You can do like 20 of them if you wanted. And we're going to do the same thing here. I'm going to do like 4 of them. All we're doing is multiplying it. Right now we're just forgetting about the equation we have to solve. We're just focused on the bookkeeping right now. So I got the 3 all from the problem, and then I got the 2 all from the problem. And I'm going to just go down the number line. 1, 2, 3, 4. 1, 2, 3, 4. You can start at any number. I suggest maybe 1 or 2, starting at the very top so you don't miss anything. And you're just solving. I have a 3. I have, 1 times 3 is 3. 3 times 2 is 6. This is a 9. This is a 12, right? Okay. Then the same thing here. 2 times 1 is 2. I have a 4 here. This gives me a 6. This gives me an 8. So what are we doing this for, the bookkeeping? Well, we're trying to figure out how to make the boots match, because originally we had a 3 at the bottom, we had a 2 at the top. 2 at the bottom. They don't match. I got to make sure I got the same shoes on. How do I do that? Well, let's just start at the very top. I have a 3 here. Do I have a 3 again at the second part? No, we can't use him. What about a 6? Do I have a 6 in the second part? Yeah, I do. I have a 6 right here. I got a 6 right here. Perfect. Let's try to see what else we got. What about a 9? Do I got a 9 in the bottom part? Nope, can't use it. 12, do I got a 12? Not right now, no. Well, let's keep going. Do I got a 2? I'm at the second part of the fraction now, but do I have a 2 at the first fraction part up here that I was messing with? No, I don't. What about a 4? Do I got a 4? No, certainly not. Do I have an 8? No, I don't. It looks like I only have a 6. So I'm stuck with 6. So how do I set it up? Because I know the answer is 6. I know the bottom answer is totally going to be 6. But how do I set it up when I go back to the problem? Well, here's the thing. This whole thing was just a bunch of 3s, remember? Then we did 1, 2, 3, 4. We went all the way down. So we're going to put any number we have on the second row into that. Meaning, here's 3, and I put a 2 there. Because here, right here, it told me to do that. What about this part where it's a bunch of 2s? What do? Well, I have a 3 there because it makes 6. Put that there. Great, great. So can we solve it now? Not exactly. Remember, what we have to do is we have to make sure the bottom is the same, which it's getting there. But whatever we do downstairs, we got to throw directly upstairs in the same house. I can't throw it in someone else's house, right? So the 3 has to go directly upstairs in my own house. Now we can do it. Now we can finally solve the problem. 3 times 2 is 6. And then the same thing here. 2 times 3 is 6. Looks like my shoes are exactly the same. Now I can work on the different hats. Let's see. 2 times 2. I have 4. 1 times 3, I have 3. We keep the boot the same because the 6 represents the boots that we were working on. 4 times 3 is 1. This is the final answer. What about this last expression, 4 over 3 minus 1 over 9? How do I do that? Well, I could do the flipping method if I wanted. I can just put a 9 here, I could just put a 3 here, and I could just throw it upstairs like we were talking about. I could also do the bookkeeping method where I just do a bunch of little tiny baby problems and see which matches. Or I can just kind of eyeball it. I can eyeball it. Let's see, because I have a 9 here, and I know the 3s and the 9s, they're buddies with each other. I know personally that 3 times 3 makes 9. It gives me a 9. I don't have to use both fractions to change my boots. I can just change one boot. I don't have to change both of my shoes. I can just change one shoe. So 3 and 3 is 9. So whatever I do downstairs, I got to throw upstairs in my own house. The second fraction, 1 over 9, I didn't mess with them. I don't have to throw anything upstairs. I didn't do anything downstairs. So let's try to solve this problem. 3 times 3 is 9. And then I have 4 times 3, which is 12, minus sign. Well, we just keep it 1 over 9 because we never did anything to the second fraction. We didn't mess with the second boot. We just had to fix the first boot. So it's going to be 12 over 9 minus 1 over 9. The boot represented by 9 goes in the bottom. 12 minus 1 is 11. Great. So this, in fact, is the final answer. So with subtracting fractions and adding fractions, number one goal is to always make sure that your shoes are exactly the same. You can mess with both shoes, you can mess with one shoe. You can do bookkeeping where you just do a bunch of little math problems, or you can just flip the numbers over, and then whatever you flip or whatever bookkeeping you do, when you put it in the bottom with your shoes to change, you've got to throw the same stuff upstairs. And then you just solve the problem. So I hope this helped. Okay, thanks guys.